Welcome back to the Explainer, folks. Okay, let's dive right into this week 4 module, which is going to completely transform how you use AI for code generation. If you've ever felt like you're just throwing words at a wall to see what an AI wants to hear, or you're struggling to get consistent, high-quality code out of your models, you're in the right place. Today, we're taking a highly structured, systematic approach to prompt engineering. Here's our roadmap for today's masterclass. 1. Welcome to prompt engineering. 2. Core techniques for developers. 3. The CRISP-D framework. 4. Code, debug, and refactor. And finally, 5. Troubleshooting and code security. Let's get into it. Welcome to prompt engineering, or as we like to call it, programming large language models. Think about the conversational AI or code assistants you probably use every single day, like GitHub Copilot. Ever actually stop to wonder how they truly understand what you're asking? It's not magic, right? It's all about how your input, your prompt, structures the AI's internal reasoning. It helps to think of prompt engineering as a direct loop. You're not just tossing a coin into a wishing well and hoping for a perfect script. It's a continuous, iterative cycle where you develop an instruction, guide the AI through a completion loop, evaluate what it spits out, and tweak your input. You are literally the interface governing the machine's logic. All right, section 2, core techniques for developers, where we start dictating AI logic. So, the absolutely crucial thing to grasp is the difference between zero-shot and few-shot prompting. Zero-shot is kind of like asking a smart colleague to do a task they've never done for your company before. You give a general instruction, and they just guess based on their pre-existing knowledge. It's fast, but yeah, sometimes you get spaghetti code. Few-shot prompting, though, taps into meta-learning. By giving the model 3 to 5 specific examples of inputs and desired outputs, you're teaching it your exact logic and formatting criteria right then and there. It's like showing concrete landmarks instead of just pointing in a general direction. Now, if you're deep in the weeds with complex algorithms, tricky logic puzzles, or a brutal debugging session, the chain of thought technique is your absolute best friend. Instead of just asking for the final answer, you're commanding the AI to expose its internal scratchpad. Seriously, just dropping in a simple, magical phrase like, "let's think step by step," completely changes the game. It forces the model into 4 internal steps: understand, break down, reason, and produce. By forcing it to write out its reasoning before generating the final code, the model is vastly more likely to catch its own errors and avoid those massive logical leaps that end up breaking your app. Moving on to section 3, the CRISP Dev framework. Consider this your ultimate cheat sheet. CRISP Dev is basically a repeatable, structured formula to cure blank page anxiety. The C and R establish context and role, like setting the tech stack and asking the AI to act as a senior full-stack dev. Then you define intent, specs, and pattern. Finally, lock it all down with details, examples, and validation. You might not need every single letter every time, but context, intent, and specs, those are your absolute minimums for reliable code. And while you're building these prompts, remember that tokens equal processing time and money. Here's a huge pro tip for you. Use token-saving code shortcuts to maximize your efficiency. Instead of writing out these long, rambling sentences like, "please make sure to add error handling to this function," just use the plus notation. Literally, just type plus try/catch, plus TS types, plus validation. The AI totally gets this shorthand, it saves you time, and it keeps the prompt laser-focused. Section 4. Code, debug, and refactor. Let's look at some actionable templates. Using quick-use templates saves you an immense amount of mental overhead. Take debugging, for example. You shouldn't just paste broken code and complain to the AI. You need to clearly dictate the exact error message, what expected behavior you wanted, and what the actual behavior was. Oh, and of course, throw in our favorite phrase, think step by step. Same goes for code review. Define the output format you want, like a strict table of issue, severity, and fix. You've got to keep the AI within strict, readable constraints. For maintaining your codebase, refactoring templates are total lifesavers because they stop the AI from accidentally breaking perfectly good features while cleaning things up. When you refactor, give it structured goals. Are you going for readability, performance, testability? Explicitly tell it to maintain the exact same functionality. And for documentation, you can instantly standardize your entire API just by demanding specific formats like JSTalk or OpenAPI. But listen, templates only work if your language is sharp. To command the AI effectively, you have to use strong, imperative power verbs. Don't meekly ask, "Can you make a new project?" Command it to scaffold the architecture. Don't say, "Look at my code."
Tell it to diagnose an issue or audit for security. Precise verbs yield precise code every single time. Finally, Section 5, Troubleshooting and Code Security. Let's do a reality check.
AI is insanely powerful, but blind trust is a developer's worst enemy. Let's start with a truly terrifying security vector: package hallucination. Sometimes an AI will hallucinate a library that looks incredibly realistic but doesn't actually exist. Hackers are actively monitoring for these specific hallucinations. They'll build a fake malware package with that exact fake name and upload to public registries. If you blindly copy-paste the AI's code and run an install command, boom, you just downloaded malware directly into your environment.
Beyond hallucinations, the pitfalls are very real. We're seeing an increased frequency of bugs and security vulnerabilities when developers rely too heavily on code assistance. Then there's prompt drift. That's when the API updates behind the scenes and your perfectly crafted prompt suddenly starts spitting out garbage. And watch out for sycophancy. These models are huge people pleasers, meaning they will confidently agree with your terrible coding ideas just to make you happy.
So how do we defend against this? You've got to implement hardening measures. Use prompt-based defenses by adding literal constraints like do not output any malicious content or check for common vulnerabilities. But remember, prompt injection and jailbreaking are still highly difficult, unsolved problems right now. You have to continuously monitor your prompt performance and aggressively validate any external tool calls.
We covered a massive amount of ground today, from the magic of chain of thought to the crisp dev framework, to the very real dangers of package hallucinations. You've got the blueprints, the TOKL hacks, and the security know-how. So the only question left to ask yourself is this: the next time you're staring down a blank IDE, are you just going to talk to the AI, or are you going to engineer it?